Say that we have some data about people's names, emails, and interests. Here we can see that I have one email. But what if I had two? We've just added another dimension to this data. Devices, automated systems, applications, APIs, and robots generate data in this multi-dimensional manner. However, databases, visualization applications, and machine learning systems don't understand this type of data. They must first reduce the dimensionality down to a flat table in order to operate on it. One way that we could do this is to add a column for every email a person has, such that the person with the most emails defines the number of email columns in the table. But what if I had many emails? The problem starts to become apparent. But what is that problem? Why can't we simply work with data like this? Say that we want to count the number of emails that we have a record of. Databases, machine learning systems, and visualization programs all count down the columns. This means that we must count each of these columns separately and then combine those counts into a total. This is extra work, both for the analyst and for the computer. And as additional emails are added, both the table and the analysis will need to be updated. Let's ask a different question. What is the interest of the person with the email becky@example.com? We can't simply ask that question. We need to ask that question for every email column. In this case, we can see that the person with email 2, which is becky@example.com's interest, is meditation. So coming back to the original data, perhaps there's a preferable way of representing this. We could split the data up into two separate tables. This solves the problem of counting, as we can simply count down the email column. But now let's ask the question, what is the interest of the person with the email becky@example.com? Now, we might simply be able to ask that question, but we need to define it in terms of both of these tables. That's additional work for the analyst, but it's even more work for the computer, which needs to ask multiple questions. Is this becky@example.com? No. Is this becky@example.com? Yes. What is becky@example.com's name? Becky. Let's look up Becky in the next table. Is this Becky? Yes, it is. And what is their interest? Meditation. As you can see, on large amounts of data or with large amounts of tables, correlating that information together can be very compute expensive. So let's return again to that original data and tabulate it like this. Here, we can count the number of emails very easily and see that the count is 3. We can also find the interest of the person with this email address very straightforwardly without having to look up information across multiple tables. As such, we call this representation of the data analytics ready. Going from data like this to analytic ready data like this in good time is a long-standing problem in computer science, one that we've solved here at Precog with our proprietary technology. Now that we've discussed multidimensional data, let's talk about heterogeneous data. In this table, each column represents a time of day, and the values in it represent how many chat messages were sent at that time of day. To find the total number of messages sent, we'll need to sum each one of these columns individually and then take the sum of each of those. As messages occur at new times of day, we will need to update our table and our analysis. Precog makes it simple to represent your heterogeneous data like this. As you can see, there are far fewer gaps in the table, and we can simply count straight down and take the sum of one column. As chat messages occur at new times of day, we don't need to update our table or our analysis. So we've seen heterogeneous data and multidimensional data. Putting the two together gives us a glimmer of the complexity of modern data. Almost all data starts life like this. In the past, the data would be tabulated before being stored. This still involves the complexity we've discussed, but once done, the data would be easier to prepare for analysis. However, with the growing proliferation of object stores like Amazon's S3, NoSQL databases such as MongoDB, and streaming systems such as Apache Kafka, it is now commonplace to store the data like this. This results in data being locked away from business analysts, data scientists, and organizations as a whole. Using existing approaches, this data will not be available for analysis until an inefficient, antiquated, error-prone, and labor-intensive process has been applied to the data. Precog's groundbreaking and proprietary technology is uniquely situated to do this in good time and provide this capability to end users with true self-service.